Next up is Adrian Herrera from Caringo, who will be talking about how to store, deliver, and archive content on the same servers with searchable object storage for the cloud age. Adrian?
Thanks, Eric. So just want to take a quick poll. So how many people are actually on the back end, the infrastructure side of video delivery? Okay, and then the rest, application side, kind of front end side, content management, that kind of thing? All right, just want to take a quick poll to know how to position everything. So Caringo, who is Caringo? We've been around for a very long time. You've probably never heard of us. We're one of the best kept secrets in the storage industry. We're object storage experts. We've been doing this for about 10 years. Arguably, we were one of the first companies, if not the first company, to deliver object storage as software. We are used by some very large organizations like Department of Defense, Department of Justice, City of Austin. We're the back end for BT's Object Cloud, British Telecom's Object Cloud. We're the back end for Telefonica. In the media space, we are the back end for InfoStrata, which was just acquired by NEP. We're used to deliver Fox Sports in EMEA. We're also used by Ask.com, 2.com, Massive Media, and a lot of IAC properties. And I'll go into some of these use cases in a bit, how they're benefiting from our technology. We're proven, we're enterprise ready. After 10 years working with the Department of Defense, Department of Justice, chances are you've worked out a lot of the kinks in your software. So we are an infrastructure layer, but I'll walk you through the benefits in the media and entertainment space. So Caringo Swarm for content distribution. Again, object storage in general is very horizontal. But when we're talking about content distribution, we're really used to store, deliver, and monetize content online. One of the major pain points we hear from our customers is, they're often ad supported, they're often subscription supported, so they really need to deliver a low latency experience, very good user experience. The content needs to be delivered quickly, because if it's not, as you can imagine, on a dating site, if you can't find who you want to quickly, if the photo takes too long to load, they're going to go somewhere else. Same thing with video. If the video isn't loading quickly, those users are going to go somewhere else. So we really focus on reducing latency on the infrastructure side, and I'll show you how we do that in a bit. What we provide is a storage layer, storage software. It installs on any commodity servers. So if you have Dell's, maybe Supermicro is giving you a better deal, maybe Cisco UCS is giving you a better deal that month, you can combine all of these servers, install our software, and it just creates a massively scalable storage cluster. We have multiple customers over a petabyte. Our largest customer is about the 20 petabyte range right now. But we also can start very small. So we have a number of content producers who deal in images that have 10 to 20 terabytes stored, and they still get a lot of value from our storage software. The reason why we're used by a lot of web properties is our storage can be accessed directly by content producers. It can also be accessed directly by content viewers. And it really enables freemium and ad-based models because it reduces latency. It consolidates a lot of the infrastructure you would traditionally need. So how is it different than traditional storage technologies, right? You all probably have Isilon or maybe NetApp in your data center today, or maybe something else. Our native interface is HTTP. It's based on HTTP 1.1. So the way you get a file, you store something, what you get back is an ID, and all you need is the address of that box and the ID with HTTP in front of it to access it. You're not messing with directories, you're not messing with folders, you're not messing with file names. Everything is already HTTP enabled. That means there's no protocol changes necessary. Streaming is enabled through range reads. So we support range reads directly from the storage device, so you're not putting an additional layer of infrastructure to support range reads. We can plug into most content delivery infrastructures. We plug into caching layers like Varnish, Nginx, a few others. We can plug into your CDN, or you can deliver content directly from the storage itself, since it is HTTP enabled. It really depends on how many users. We are optimized for many users. We have a truly parallel architecture. So we can support tens of thousands, if not millions, concurrent points of access to a specific piece of content. You could think of us as a massively scalable web server. So even though we are object storage at our core, the way we behave is very much like a web server. So let's take a look at a typical content distribution architecture. What we've seen, and we've seen this over and over again, there's lots of different variations of this, but you have the main application layer, kind of the variables that you store. Let's say if you have a dating site, you're storing everyone's eye color, hair color, height, all that stuff. That's kind of stored in the main application layer in a relational database. The bottom layer is the media content layer. So you have a media web server, a media access app, an application specifically meant to access your video, access your photos, access your audio. And then you have an additional relational database layer, to store all that. A lot of the times, I mean, you're not always supposed to store content in a relational database, but a lot of people do it. We've seen it over and over again. The issue isn't with those technologies per se, it's when you hit scale. Once you have to scale those technologies, you have to ensure protection, you have to ensure redundancy, you have to replicate them over multiple sites, then those technologies really start to become an issue. And where we come in and we eliminate that whole bottom layer. So we eliminate the media web server, the access application, and the SQL database. So what does that get you? It gets you one tier of infrastructure to scale, and you reduce latency by up to 40%. We have scenarios where we've taken 100 millisecond latency and we've reduced it to 10 milliseconds. But on average, we're around 40 milliseconds. So you radically simplify the underlying infrastructure. Also part of our technology is content management. So you can set when a file is deleted. This is very good for seasonal applications. So we're used by a very large retailer in Europe, and they have a seasonal business. So they set all of their summer inventory, the images and video that they have, to just automatically delete themselves in the coming fall. And that's all handled by the software layer. So from the developer, what we're seeing is a lot of developers are now finding themselves in charge of storing infrastructure, managing infrastructure. This lets them manage data, manage content. They just set the policies and they're able to just kind of focus on the application and not have to worry about content management. They don't have to worry about infrastructure management. So it's a great cost savings. So some of our content distribution use cases, we're used for streaming media, so we're used in a lot of video on demand solutions. The way organizations benefit from it, we do support range reads, but we're great at long tail enablement. The reason why, you can continue to evolve hardware underneath the content. So let's say, you store your content today on a specific set of Dell servers. 5 years down the road, they're going to come out with more efficient servers. You're going to need to upgrade that. Traditionally, you've had to migrate all that content to the new servers. With us, you can just keep on plugging in the new servers and continuously evolve, and that content moves to the new servers. And by that perspective, you can continue to evolve your hardware underneath all your content. We also support erasure coding. So for those of you who don't know what erasure coding is, it is a type of protection where you're able to split a file up into multiple segments, add parity information to it, very similar to RAID, but on a per content level, and it saves your footprint considerably. So in a content distribution scenario, usually we recommend replication for the first week or two when the content's hot. When it stops being hot, we use a erasure coding 5.2 method, which reduces, let's say you have 3 reps, that's about 300% over your content footprint. Well, with a 5.2 erasure coding scheme, it's only 40% above 140% of the original content. So it's just 40% above, and you're getting the same protection method. The content is still accessible, and it's still incredibly responsive. For social, we're used for photos, thumbnails, and video. Here, latency is key. Again, we support long-tail use cases. And then for long-term archive, we're used for a lot of cultural archives. So the VIAA, the Flemish Cultural Society, uses us. They normally would store their information on tape, but it wasn't accessible. They had regulations which said, hey, these are cultural media archives. We have to keep them accessible on the internet. So they used us, and they used one of our power conservation features called Darchive, which automatically spins down drives, spins down disks, reduces CPU, and they were able to get down to the cost of tape and still keep everything accessible over the web. And just to kind of wrap it up, summarize everything. So from a content distribution perspective, as far as content producer direct ingest, you can preserve content for decades, long tail enablement with integrated content management. As far as delivering, we support range reads, HTML streaming. We do plug in as CD origin storage. And we enable freemium and ad-based models. So low latency, we have integrated content search. So that's something from a developer's perspective. If you're a developer, you can search against our storage cluster. And we also have integrated power conservation, so we save you a lot of money from the data center and operations side. And we will be demoing everything at our booth, booth 114. So if you do want to see an example of kind of video streaming and range reads, we'll be demoing it at our booth. And we have a solution architect there. If you'd like, you can sit down, take a look at your architecture, and see where we can help. And that's it. I'll open it up to questions if anyone has them.
All right, again, any questions, let me know, and I'll bring the microphone around to you.
Hi, Adrian. That was very interesting. Out of curiosity, would your service also support things in terms of trying to reduce latency and buffering? Like, in other words, if you've got a client that has a lot of existing archive video or what have you, and they're trying to serve that up through multiple devices, would your infrastructure and the way it's organized actually help reduce the amount of buffering and latency for speed up playback?
Absolutely. So depending on the access patterns for the content and the access application, you can develop and access content directly from the storage cluster itself. So you should be able to, when we went over consolidating those points of infrastructure, you should be able to consolidate depending on the way you've architected your application and reduce it. So InfoStrata has many streams, and in their application layer, they've written intelligence to drop down to the different bit streams depending on the quality of the bandwidth connection that they have. So we don't do that type of technology, but we support range reads in a way that you're able to jump to different streams in the specific block that the user's in. So let's say they're in an HD stream and you have to drop down to SD. You can use our storage cluster to support that type of delivery mechanism. And we have a solution architect there, so if you want to ask them more detailed questions, we can actually sit down and you can map out your application and we can see where we can help. Right.
Any other questions? All right.
All right.